Hi, this is Prof T talking to you a little bit about Chapter 6. I went through the most of the chapter. This is kind of the second half, a little bit of a review. So I wanted to kind of help you out here and give you some extra details about the chapter that might be helpful for you. First of all, we talked a little bit already about the Open Systems Interconnection Model, or the OSI model. 7-layer architecture defining how data is transmitted. So I've found little ways to remember what these layers are. Like, all people seem to need data processing as an acronym for these. But basically it starts at the lowest level is the physical layer. Stuff like I showed you in class, the wiring. The data link is above that, the network, transport, session, presentation, and application. That's the order of the OSI model. Just be familiar with that and know that there's 7 layers to it. It's basically a set of standards that help guide the data transmission that happens. There are different types of networks. We kind of talked about it a little bit. Local area networks, wide area networks, metropolitan area networks, and then I added one for you, which is called a value-added network, or a VAN. For those of you taking the CPA, take special note of that because you might see that on your exam. We mentioned a little bit about the network interface card, or the NIC, that talks to the computer. It's basically a translation from the network to the computer itself, and it can be via a wire or it could be via wireless. If you have a laptop, you'll have basically 2 NICs. You'll have one that you could plug into the wall via an Ethernet cable, or you could use wireless of that kind. We talked a little bit about the different types of local area networks. Ethernet really is where the market's at right now. Token rings, pretty old style network, but in its day was awesome. The local area network basically allows you to connect stations that are fairly closely related or in a limited geographical area. For us, think of the Olivet campus as being one local area network. And typically the data speeds are anywhere from 10 megabits to 10 gigabits. And usually we're using Ethernet cables to do this kind of activity, or very commonly now wireless. So through your phone, through your laptop, those types of things, through a tablet device, we can use Ethernet to do that. A wide area network spans cities, can be much larger. Basically the speeds are a little bit slower typically, and depending on who and how you're connecting, you may be using some kind of other third party to deliver your network services to you, or you're connecting from network to network. A lot of times we use the utility companies to do this kind of thing, like an AT&T or a Comcast or somebody like that, Verizon if it's a wireless. Metropolitan area networks are usually set up around a city. Data speeds are listed here for you on the slide as well. So this is also called a MAN. And here's a little picture, and we looked at this, I think, the last class, where we have metropolitan area networks, wide area networks, and local area networks. A value-added network usually isn't talked about in terms of size, but what is offered. And the value added could be backup capabilities or some kind of monitoring or management that happens on that network, versus a network that you just get and have to use the equipment yourself. So we talked about all these types of network topologies: the star, the ring, the bus, hierarchical, which we didn't do a lot about, and then mesh. So these are the 5 most common. And when we're talking about networking, basically we're talking about protocols. TCP/IP, which is the way that basically all the internet traffic is communicated. We have routing, or routers. That's another concept that we talked a little bit about, how the data is passed from network to network or device to device. And sometimes data can take multiple paths. It doesn't always have to take the exact same path. And then the client-server model is a part of this as well, as a networking concept. So protocols are just these rules. When you hear protocol, think rule or guideline. A lot of times they deal with hardware, software, and networking, so that they can support this kind of exchange. But we have to kind of have some rules to agree upon. And a lot of times those rules are rules that are established by, like, the IEEE to determine, standards. TCP/IP is the industry standard for communicating on the internet. And it allows us, it stands for Transmission Control Protocol / Internet Protocol. And you can see here that the TCP portion of it actually operates at that OSI model transport layer. And the IP portion of it is actually a little bit farther down at the network layer. So there's two pieces to that. An IP address would be something, a number that looks like 158.14.2.1. And that's how we see those particular addresses. For routing, packet is a piece of information. Think of it as a small collection of maybe a larger message that can be sent over a network. The routing method that it takes, either through a static route or through a dynamic type of route, those packets can actually be broken up and can arrive in different orders, and sometimes. But the protocols are smart enough to either detect errors when packets need to be resent, or maybe they don't arrive, or if they arrive out of order, there's a way that it puts it all back together so the message makes sense when it arrives at its destination. And routers, Cisco's the biggest network company out there that makes routers. They actually make the hardware that basically drives the internet. They're one of the largest routing companies in the world. And the internet, just think of the internet as a bunch of different networks that are interconnected. So some of them are small, like LANs. Some of them are like wide area networks. And what happens is we're able to pass packets from network to network to network through this routing technique. And that's mentioned here on the bottom of the slide. You can do either static or dynamic routing. Static would be just point to point. We always use the same route. Dynamic routers could allow for different paths, so you might have different ways that those packets are being routed to get from point A to point B. The client-server model is basically deals with, there is a server that serves up the information to the client. The client has some kind of software running on it. A lot of times that's the presentation part of things. And this is a very typical way of seeing information on the network now, is through this client-server model, where you might have a database server that's on the network, and that data can be viewed on a client, which could be used as it could be just as simple as a web browser on the client side of things. Wireless networking can be used instead of wired technology. Obviously, this is where things are really moving these days. And there are different types of mobile networks. If you have ways of going from base station to base station, most wireless networks only operate in a very small geographic area, but they are flexible, mobile, easy to install. I would say maybe easy to install, and I'm not so sure about the low cost. One thing is cheaper than hiring somebody maybe to pull wires, but as we talked about in class, you do have to wire the wireless access points and get data and a lot of times electricity to them. So I'm not sure that there's a lot of advantages to wireless. It still can be very costly. Some of the disadvantages, wireless is usually slower. There are problems in reaching certain areas. So there are dark spots, even like on our campus. There are places you can go where you get a weak signal or no signal at all. So that is possible, just like you do with cell-based networks as well. So the book talks a little bit about wireless types of LANs and WANs. Typically the speeds are slower on the WANs. But anyway, this gives you an idea of just with this table of the different styles of wireless networks. This graphic just tells you a little bit about mobile network architecture, where you have networks, phone networks, and things that come together to provide base stations. And then you have these subscribers that are able to connect through all kinds of different devices, phones and notebooks, PDAs, palm tops, laptops, whatever. Even though wireless can be very easy, we have to really watch out because security is an issue. I've got a friend who likes to drive around and get into people's networks, and just for jokes, he actually parked across the street from a friend of mine who's a state police officer. and he hacked into his wireless network and was able to print something on his printer, printed a joke or whatever and sent it to him. So you have to be careful and provide security only, for several reasons. One of the reasons is you just don't want somebody stealing the services. So if somebody's sitting out in my driveway using my wireless network, they may not be able to get to anything inside my house or gain access to anything, but they're using my resources that I'm paying for. Maybe my network's slowing down because somebody else is nearby and doing that. So a lot of times with wireless, you can just pick up a signal, you can find wireless networks. So wireless security is important. The SSID, you may have seen this. This is where you see the actual name of a network. So if you do a search and you're looking on your laptop for a wireless network, the way that you see what's available out there is basically through this SSID. So if you're broadcasting that service set identifier, you can see the name of the network and you can connect to it. So one way to provide security is to blank out that SSID or not to broadcast that. You'd have to know the name of the network for you to connect to it rather than just browse around and find one by searching wirelessly. WEP is another type of security, wired equivalency privacy. The WEP key has to be entered, and this is what I use even in my house. I have a particular password that you have to enter to be able to get on my wireless network. And if you ever visit my house, no problem. I will give you the WEP key, you can connect, and then you can get on my network. But somebody driving by my house or my next door neighbor can't necessarily use my wireless network because it is improved by using this security and using this WEP security. Data, voice, and video are all coming together, and we call this term convergence, where everything's coming together. For example, you might be able to use voicemail, and instead of calling up and listening to your voicemail, maybe the message gets sent to your email inbox so that voice signal is being changed over to data. Things are coming together now. Voice, video, and data are all going on the same type of communication devices. So there's ways that we can do things even through something simple like a video conference where I can send voice and I can send a picture of myself like I'm doing now on the camera, and I might be able to even send data at the same time so you can look at the same file that I'm looking at. That's a different kind of integration that we're talking about. So just to summarize for Chapter 6 here, we looked at basic data communication systems, types of components, configurations, networks, topologies, and we've looked at a lot of the concepts, security being one of them, and some of the future trends in data communication. That pretty much takes us through the chapter, and I hope you're ready for the quiz. And as we move on, we're going to look at the internet and how all these technologies kind of come together and are used to conduct business either wirelessly or over a wired network, and how we're able to do these things even on a global scale. Thanks for watching. Talk to you soon. Bye-bye.